Alright guys, welcome back to the another video. In this video, I'm going to talk about LSTM model, which is very useful for the time series analysis. And for this particular video, I'm going to forecast the temperature based on several variables such as dew point temperature, humidity, and pressure, etc. So let's get started. First of all, let me talk about LSTM model. So the LSTM stands for long short-term memory. It's type of the recurrent neural network architecture designed to handle the sequential data such as time series data or such as like the language. And the LSTM is mainly applicable in natural language processing, speech recognition, and importantly for the time series analysis, time series forecasting. So the below diagram shows the like very basic concept of LSTM model. So there are mainly like three steps. So the first thing is like it will try to forget the irrelevant information, and then in the second step it try to add or update the new information, uh, which of course achieved by training the model, and then it will pass the updated information to the model, and then it will simply loop it and then simply run it for the several time to get the best accuracy. So yeah, so that's how it works. So talking about my data set, my data is the temporal data. Of course, temporal means the time series data, and there are total nine variables that I'm going to use, which are like dew point temperature, humidity, rain, snow, and thunder, etc. So the data I got from the Kaggle. So here they have the testset.csv file, and of course you can see it. It start from 1996. 11, which is November 1 to I think it's 2017 or something. And then they have like hourly data set. So in my model I'm trying to like compress it to the daily data set by averaging the daytime temperature, and then try to predict that day average temperature. And here you can see they have like different variables like dew, ptm, fog, hail, and heat index, humidity, precipitation, pressure, rain. Of course we don't need all the variables, so of course you can try with all the variables, and then you can try with only two or three variables. But for this particular video I'm going to use only, I think, nine variables. So yeah, let's go to the presentation mode. And okay, so my workflow here is to first I'll do the data pre-processing. So that means I'll remove the non-required field, and then also there are few like non values, so I'll try to like fill them based on the uppermost value, uppermost like the temperature. And then I'll also create the numpy array in the required format, I mean the required shape. And after that I'll train the model using LSTM model, and then predict the temperature, and then I'll show you the graph in a minute. Okay, so since I already did it, so my loss function, my like history look like this. So my, in this graph you can clearly see that my model is like improving slightly, my loss is like decreasing. So I'll train and show you after this presentation. And this is the result. So the actual temperature is represented by blue line, and then the predicted is in the uh, orange line. So it looks like it did pretty good job during the prediction. And yeah, of course I'll show you. So let's go to the coding section now. All right. So for now, I created the like Google collab with LSTM weather tutorial. And here is always I need to like import the main packages. So I'll import numpy is np, and then pandas is pd. So that's what I need in order to pre-process my dataset. And also I'll import the matplotlib.pyplot is plt in order to like generate the graph. And also I can like add another library, c1 is sns, which is also for the like generating the graphs. Okay, so if you encounter any import issue, then make sure you install this by pip install that library. And of course I need like google colab, so I'll write from google.colab import drive, and then I connect my drive.mount, and then uh, slash drive. Okay, if you connect the drive properly, then you can see your my drive folder over here in the folder menu, file menu. And make sure you download this dataset from here and then upload it somewhere in your drive. So I renamed the file name is delhi weather data.csv. And so after that, here is my data, and then I copy my file path, and then I'll write data path equal to, and then the path. And if I like create the data frame with pd.read csv, and then data path, and you'll be able to see the data set. So here one thing I notice in the actual that csv file is like in these particular columns there are like some extra spaces. So I'm going to remove that spaces. In order to do that, you can write df dot columns equal to df dot columns dot str dot lstrip. So it will remove the space from like beginning. And then again you can write dot rstrip to remove the backward space. And then if you write df dot head, then your result will be similar. Sorry, then your result will be similar, but this time you already removed the like extra spaces from the columns. Okay, so the next step is to, I'm just going to like show you how scattered is your temperature. So in order to like plot that temperature, so you can write plt dot figure, and then you can write the fig size is I need bigger one, 15 comma 10. And then you can write you can create the hist plot based on df dot my temperature is this one. So df dot based on this property. And then your bins will be like I, for I in range 0 and 61 and 5. And okay, and kde equal to false. All right, so this is the like distribution of temperature. And then these are like totally optional things, so you can write the title and then this grid box and plt so to show your plot. And this is the temperature value. So I think all most of the like temperature value lies between 25 to 30. And you can see it from 30 to 35 also there is like high value, almost around 25,000 temperature values lies between these two uh, category. And also like almost the temperature is starting from like 5 to 10 degree. In delhi there is like below 5 degree there is like no temperature below 5 degree, and then no temperature above 50 degree. Of course it's centigrade. All right, so now it's time to like set the index of your data frame. So I'll write pd to data date time. So since I'm using the temporal data set, so I'm going to make it like date time index here. So previously I have like this index is 0 1 2 3 4, but this time I set my index is like the actual date field. So it might take some time, but yeah, here you can see that. So actual my date time index is lies here, and then these are my column names, and of course you can see another column name is date time UTC. And right now I'm going to like copy few line of code from my previous notebook and I'll explain. So right now my required column will be like dew point, temperature, fog, hail, humidity, rain, and these few of these columns. I simply want to drop few of the column like the cons, and then the pressure yam, and maybe the wind direction, something. So I simply drop that columns, and then as I mentioned in the beginning, so I'm going to use only 9 variables. So I simply filter it, and then if I see df dot head, then I can see only the 9 columns. All right, so now it's time to like check the number of non values in each columns. So in order to do that, you can write df.isNone.sum, and then it will list out the number of non values in each row. So right now I have like dew point temperature, there are like 621 values which are none, and humidity 757, and then temperature 673. So what I'll do in this case is like I'm going to like fill those non value based on uppermost value. So in order to do that, so I can write df dot fill non and method equal to fill, which means a fill from forward. So if I say df dot head, it will be like similar, but this time my non value will like go is non is na, and then sum. So now I don't have any non values, so everything is filled. And now it's also like time to like resample this to the daily data set. Since it's the hourly data set, you can see we have the data set from each hour. So I'm going to like make the daily data set. In order to do that, so the uh, it's very easy with the temporal data frame. So you just need to like resample it by day. If you write d, it will be the day, and then you can write the mean. That means you are going to average it. And then if you df dot head, then you'll see we no longer have this hours, so we have only the date, and then these all values are like resampled based on day, and then these are the mean values. If you want to resample it by month, then make sure you write m, and if weekly then w, and if hourly then s. Since we already have hourly data set, so that doesn't make any sense. Now again it's time to like check the non value. So here you can see all the values has like 141 non values. Looks like there is some like missing date, so in which the weather station is unable to like detect, measure those matrices. So in order to solve that, again we are going to like use the ffill method. is previous. So maybe I can copy this cell and then paste it over here, and this time it will be like instead of df, it will be df final. Okay, now again we can check this, we can again check this cell. So now it has like all the like columns were filled by ffill method, and then now we don't have that, uh, missing values anymore. Now again, in order to like make this data set in the like actual good format, is like required in LSTM model. So I'm going to like copy and paste some line of code, and then I'm going to explain what's going on here. So let me explain. So first of all, we use the min max scalar, which is like normalization of data. So if you want to achieve the best accuracy in your model, then make sure you need to like normalize these things, normalize the data. So what this min max scalar do is like, if the like temperature, it will just take the minimum and maximum value from each column, and then try to like subtract, I mean try to compress it into the value between 0 to 1. So it will relatively change all the values, so that we get all the like points, all these numbers between 0 and 1. And then now we are doing the like scale data is the same scalar, and then we are like scaling everything in the df final, which is over here, this data frame. And after that, we are trying to like make the sequence length of 10. That means it will take all the variables from 10 days, from like previous 10 days, and then it will try to make the sequence of 10 days, uh, and then try to predict the 11th day temperature. And here our number of feature is df final dot columns. Of course you can replace it by 9 because we have 9 columns. And here I'm creating the sequence and corresponding labels. So first of all, I create the like empty list. This loop here is the most trickiest part, and then this is the most essential part. So in order to explain that, I'm going to like again print out the my data frame df final dot head. This time I'm printing I think around 12 data set. So yeah, so here, so from this loop, what it is doing here is like it's creating the sequence and the label. And here, for example, our sequence will be like the all the variables from up to 10 days, even containing temperature data set. But our like label will be the 11 days temperature, which is 22.086 degree centigrade. And then for the second iteration, it will take all the values from date 2 to 11, and then our predicted level will be 23.45. So that's what it's doing here. So you can like simply read it, is explained here. So I'm here in the second line, I'm taking the sixth variable, which means like index is starting from 0, and then it's the temperature 1 0 1 2 3 4 5 6. And also like simply after like creating my sequence and label, I'm appending those to the list, and then later I convert them to the numpy array. In order to like train deep learning model, you need to like pass it as a numpy array or pandas data frame. That's how that's why I created numpy array. And here I try to like split the training set and test set. So I'm like simply splitting them based on 80 to 20 ratio. And here I simply selected the first 80 percent of my data is the train set, and then last 20% of my data is the test set. That means these are of course the date time index time series data set. And then I'm like simply printing my train x and train y, test x and test y value. So it might take some time to like run, but I think it's quite fast. So here you can see we have like this much of like a trend set, but we have the like 10 sequence with 9 variable, and then our label is all the like based on this 10 sequence and 9 variable, we have only one value is the prediction, which is of course the temperature. And then here also we have 10 to 9 variable, and then of course we have like one output is a label. All right. So the another important thing is to like create the model. So in order to like create the model, so there are like lots of options. So you can search for the open source any like GitHub repository, or even you can ask for the chat GPT. To be honest with you, I also asked for this particular model in the chat GPT, and then I try to like adjust some of the parameter. So that's how I came up with this model. So here let me explain few things. So I'm importing the few like required things over here, and I'm creating the sequential model. And then in the model I'm adding my LSTM model, of course with 128 at the beginning unit. And input shape will be like my shape of my data set, which is like 10 comma 9. And of course I need to like pass this important, this is the like important things here. So I need to return this sequence as true, but at the end of my model I need to like make it false, so that it will be able to predict this time. Otherwise I need to like pass my sequence over another LSTM model. And I'm using this dropout function 0.2, of course in order to like reduce the like overfitting complexity. So in order to like get the more accuracy, so I added three dropout functions. Of course it's up to you, you can like modify this model or make it more like more dense, but for now I feel like I am just trying to like detect the temperature. That's why I added only three layer LSTM layers. And at the end, so you need to also add the dense layer with the unit 1, which is the output layer. And of course you need to like compile it with the like optimizer. Of course as far as I know, the Adam optimizer is the good one, so I always go with Adam. But if you know any better optimizer, then let me know in the comment section as well. So and also the loss function is the like also essential one, since I'm doing the like regression kind of problem. So I'm trying to like get the prediction as a number, as a like temperature. That's why I wrote it as mean square error as the loss function. So simply run it. And after that, so if you like write the model dot summary, then you will see all the model and then total parameter, trainable parameter and non-trainable parameter. Of course we don't have any non-trainable parameter, but it looks like I have like 132 132,000 parameters. So yeah, so we need to like train this model. So now in order to like train the model, so the two best things that I always try to include are like early stopping and then the modal like checkpoints. So let me copy some code from my previous repository and explain here. So early stopping, I try to like add these two callback functions. So this early stopping, what it will do is like it will monitor the val loss, which is like run in the validation data set. And it will like monitor the loss value of that particular like epochs, and then it will simply run it till like we get five consecutive non-better values. Then it will simply try to like stop. The purpose of this early stopping over here is to like save our time. If the model try goes uh, like the if the model went to the overfitting stage, then it will simply try to stop our model based on like five consecutive values. And then of course I'm restoring the best weight is true, and then model checkpoint. So this is to like save the best weight. So here I have the like location to the best weight function. So since I already run this function, so I have already like best model weights over here. But anyway, I'm going to run it again, and yeah, it will also monitor the val loss. And here in the history, actually during fitting the model, so I'm passing my train x and train y value, and then I'm running it for like for now I'm planning to run it for 100 reports, and then batch size will be 64. Of course, you can make it smaller or even bigger, and then validation split is zero point 0.2. So what happened here is based on like this train dataset, so it will simply again split our training dataset by 80 to 20 ratio, and then it will train based on the 80% of data, and then validate our model based on 20% of data, and then get the more like nice accuracy. And then I have two callback functions, and let me run this. And of course it will take much more time, I think around 10 minutes or something. So I'll resume the video after like training this model. One thing here I want to explain one thing. So we are just tracking val loss. If the val loss is lower, getting lower value, then that means our model is still training and then it's doing well. And if it start like increasing, then that means it's not a good it try to overfit the model. So that's why I'm simply tracking this val loss function, and then if it start increasing, then as I mentioned here, we have the early stopping check pointer, which is like callback function. So if it start like increasing for five consecutive epochs, then it will simply stop our training model, and then it will only save the best weight. All right. So as you can see here, so I initially set up my epochs, number of epochs to 100, but it stopped training at 41 epochs. So the thing is like it already achieved in the val loss of condition 0.0022. And but after that it seems it's not increasing. Seems it's not decreasing. That's why it stopped like training the model. So that's and then of course our model is like model weight, best model weight are saved over here in the drive. You can see the time, uh, it's the current time. And okay, so now it's time to like evaluate the model. So okay, maybe I need to import TensorFlow as tf, and then I'm going to load my model from this particular directory. And after that I'm just testing the test loss, and best model dot evaluate test x and test y, and then test loss will be like printed over here. Okay, so now our like best weight test loss is 0.0020. So yeah, so now another thing I would like to like show you is the like history. That means how our model is trained. So history loss and val loss. So val loss is val loss refer to validation dataset, and train loss refer to training dataset. So that's how our model is like trained. So you can see our like gradual decrement in the loss. So that means our model is training, and then it's trying to like do the pretty good job. Okay, so now in the thing is like also you can check other kind of like accuracy metrics. So in order to do that, you can uh, simply get some of the matrices from scikit-learn package. Of course, here I'm simply trying to check the mean absolute error, and then mean square error and root mean square error. So simply if you run this function, so here I'm predicting the my prediction based on test data set, and then after that I'm passing my actual value versus prediction, and based on that we can get that like RMSE of 0.045, which is pretty good. uh, yeah, so yeah, now it's like time to like predict and get the actual temperature. So in order to like do the actual temperature, so we also need to like reverse inverse the transformation. So here what I'm doing is like test y copies. So first of all, like I'm simply copying my test y values up to like the I think 9 times, 10 times, because 9 times because there are 9 variables at the beginning, and then I'm also trying to get the true temperature based on like scalar dot inverse transform. Of course, this inverse transform will like convert my actual like as you convert it to the actual temperature as I mentioned over here at the top. So we did some kind of min max normalization, right? So this our temperature value will lie between 0 to 1. That's why we need to like do the inverse transform in order to get the actual value. That's why we are doing here the inverse transformation, and then we are getting the sixth index, which is the temperature. And for the prediction, here we predict based on our test x value, and then we are like repeating this 9 times. That's the like number of variables in my model, and after that we did the inverse transformation, and then we try to get the temperature. So yeah, so just hit run. And okay, so after that, of course, you can like try to like show them, plot them in the matplotlib line chart. So here I'm just plotting the last 100 results. Minus 100 means the last 100 index up to the last index, and then true value. These are like the indexes, that means our like the actual date, and then this is my true value, and then this is my predicted value. And if I hit run, so you can see this kind of graph. So it looks like, yeah, the trend is pretty similar, so doing the pretty good job in the temperature prediction. Yeah, so yeah, so in this way simply you can like predict the temperature, uh, daily average temperature based on your weather data set. If you have your own country weather data set, you can simply try to get the like required variables, and then make it like pre-process your data set, remove the non values, and after that you like make your data set in the numpy array, as I showed you in the required format like 10,9. And after that simply train your model and then get the result. So looks like the trend is pretty similar, and then it did good job. I'm really happy with my model, and actually the RMSE error is also like less. So yeah, so that's all about like LSTM weather prediction, the temperature prediction from Delhi. So I hope you enjoyed it. So if you enjoyed it, make sure to hit the like button and subscribe to my channel. Thank you for watching.